Hey, what's going on? Welcome to another episode of AngularAir. I'm your host, Justin Schwarzenberger, and on today's show, we're going to be talking ngrx and Angular. We're going to see some demo code. We're going to discuss what it's all about. I think it'll be great, so glad to have you guys joining in, and hopefully everybody can learn some great stuff. So our panelists on today's show, we've got Austin McDaniel, the birthday guy. Austin, how's it going, and happy birthday.
Good, thank you. It's going good.
Good, good. And we got Mike Brocky joining us. Mike, the new owner of figuring out how to do that digital taskbar on that MacBook. How's it going?
Not too bad. Just trying to figure it all out and trying to get it all set up. I was happy to join in on this machine today. Also, happy birthday, Austin. Your gift from me is that I will not sing.
There we go.
I actually had Alexa sing to me this morning.
How did that go?
Alexa, sing me happy birthday.
Happy birthday to you. Happy.
Nice, nice. That's awesome. All right. Well, good. We're off the hook then. We don't have to sing to you. All right. Our guest on today's show, we've got Mike Ryan. Mike, how are you doing?
I'm doing very well. How about yourself?
Doing great. Doing great. We're really excited to have you here. Hopefully you can enlighten us on this ngrx story and show us some cool stuff.
Definitely. So yeah, I joined the Angular community about a couple of years ago, and I became actively involved with open source probably last June when I started working on ngForward. If you haven't heard of ngForward, it was at the time sort of a cool way to maybe write Angular 2 style code and Angular 1. And one of our hardest difficulties was trying to port the async pipe to Angular 1. And we never got far with it, but that sort of started my path on full reactive Angular applications.
Nice. Cool. So, okay. So, and now you're doing this ngrx thing. Why don't you tell us a little bit about that?
Sure. So ngrx was started by Rob Wormald. He is a developer advocate on the Angular team. And it was started with the mission of making really small, simple, easy-to-use reactive libraries that played great with Angular 2. So our biggest project by far is ngrx Store. And Store is it is a reactive implementation of the Redux pattern. So you can imagine that all the state that exists in your application is one observable, and this plays really well with, like I mentioned, the async pipe and all the other reactive primitives that exist in the framework.
Okay, and when you say state of our application, are you talking state like the way things are displayed in the UI and set up in terms of like what's showing, what's hiding, or data as well, kind of everything?
Kind of everything, really. So if something could happen that changes the way the app looks, you know, you've loaded some data or the user opens a modal window, all of that is state. And so it's sort of an abstract idea. But yeah, it really does encompass a lot of the business logic of your application will be, you know, is contained in your state of the application.
Okay, so essentially as things change throughout this process of somebody using our application, every little change that goes on is recorded in this state, and then we can react, our application can react to that state. Is that correct?
That's sort of correct. So the state is not a record of changes that have occurred. We actually model changes through actions. And so there's this pattern of event sourcing, which is in an application, especially front-end applications where you're probably using Angular, there's a lot of different event sources that are sort of connected to your application. So an event source might be your users interacting with the application. That'd be a good example of one. Or making REST calls to a server, or connecting to a WebSocket. And so what we want to do is we want to take all of these action sources and say, okay, I'm going to describe this change in a consistent way. And that way is with an action. And an action has a type, which describes what exactly occurred. And it may also have a payload, which would be information that that action contains. And so once we've modeled all of the events in our application using actions, then what we can have is we can have listeners for these actions that change state. So you can think of state not as a collection of all the actions, but as sort of a projection of all of the actions that have occurred in an application.
Nice, nice. And so, go ahead.
With a buy-in to a framework such as this, where you're trying to keep state of your application separate from the application, does this require 100% buy-in throughout your entire application, or would you be able to apply this pattern piecemeal in maybe only particular areas, or if you have a large application and you want to migrate some parts of your application incrementally?
Sure. So it's sort of important to consider what Redux was invented to solve in React world. And one of the big challenges that they found when they're doing these component-based applications was that it can be awkward to write components that have to pass a lot of props down the component tree. Props are sort of like Angular 2's inputs. So Redux as a shared state container makes a lot of sense when you want to share state across components, but it doesn't have to be all of the state. It sort of solves this pressure of, well, how much information do I need to pass down my component tree versus how much could I share in a shared service? So to answer your question more closely, I would say you could definitely do it piecemeal, and it might not always be smart to keep all of your state in the store, maybe just your important state.
What are some good examples of things that are not good to keep in the store?
Sure. So it's little things where it'd be more awkward to keep it in a store than just to keep it sort of localized. One example might be like an alert that you want to dismiss. If you're trying to wire up reducers and actions that might handle the state of whether or not that alert is shown or not shown, that could become really awkward. So I'd say a lot of UIs state like that, whether or not a box is showing or something like that might not be real smart to keep in a state container.
What about, routing and things like that? Should those be included in your state?
So it does not have to be, but we think it's best if it is kept in your state container. And we actually have a project in ngrx that was designed to sort of solve this problem. It is led by Brandon Roberts, who does a lot of the documentation for the Angular router and helped design it. And what it does is it synchronizes state for you. So you don't even have to think about keeping or writing all the boilerplate to keep the router state in your store. We try to handle that for you automatically, and then you get all the nice parts of doing such, like rewinding state or some of the other really cool instrumentation that Rob showed off before.
So let's play like I haven't seen that. What are some of those instrumentation tools that you just mentioned?
Sure. So the one that everyone likes to use the most is called the Redux Chrome extension. And despite the name, it does play wonderfully with ngrx store. I'm sure we'll demo that in the code demo later on. But what it does is it keeps a record of all the actions that have been dispatched throughout the life cycle of your application. And it records what the state was at that time for that action. So what this allows you to do is, first, you can break into your state tree. So this can be really helpful to see how does a specific action actually cause changes in my state tree. I can get a nice visual diff of those changes. But it also lets me go back in time and actually view my application at any point in that tree. And this could be a real productivity saver. We get a lot of value out of it when our application might be like in a loading state and we want to work a lot in a loading state. Getting to just jump back in time to when our application was in that state and develop from that point of reference saves a lot of effort.
Yeah, that's really cool. I've seen some of that, seen that on the Redux stuff. What about, do you do that in production, right? Do you have the ability for people to rewind? Is that something that I would want to do?
Maybe. So we leave that option up to you. When you set up the instrumentation for ngrx store, you can set it up in a way where it will only actually instrument if the extension is present and installed on the user's browser. So the assumption might be that if you have the extension installed, you're a developer and could probably already get to the state anyways. So then we turn it on, we turn on instrumentation, and you can have that in your production app. But for most users that don't have that extension turned on, they don't suffer any penalty from this instrumentation.
That's really slick. I like that. I like that concept.
What about, is this, state tracking, is that useful to put in my app? Let's say I've got like a chart that I'm like kind of changing some of the attributes on or something like that. and I want to rewind that. Are people using this type of thing for, actually in their app, not just in the instrumentation?
Definitely. It provides a really great undo, redo API just sort of out of the box. So if you want to leverage that instrumentation in that way, you can do that as well.
Yeah, one of the things that we kind of look at in terms of thinking about, go back on the point a little bit about what do you think about what you put in your state and what you want to store. We kind of go back to this point of the replayability, right? And the ability to take a state and get our app launched using that state. And if that information is imperative to putting our app back into that thing that we want to see, then it's a good fit for going into the state. And if it's something that's not really consequential in that, then maybe it doesn't go in the state. That's kind of an approach that we've taken.
Yeah, that definitely would be the same advice I'd give a new developer as well. And another helpful benefit of doing this and using this extension, we have customer operation personnel who are trained to use these tools so that if a customer interacts a bug with our application in the field, they can download this snapshot as a JSON file that has all the actions and all the state that got us there. And we can replay that back in-house and see, okay, how did they find or encounter a bug in our application? What series of actions and steps took place to get us there? So we also find it really helpful from a debuggability aspect.
That's really cool. What about, what if my state gets crazy huge, right? Is there not a penalty for the browser, keeping track of all these states throughout the whole life cycle of a user experience?
So if you have the instrumentation turned on and you have this massive state tree and you're going to be changing it frequently, you're definitely going to experience some performance hiccups. That's why in some cases you might not want to have that instrumentation on. Recently, we've been sort of in that situation where we have a tremendous number of objects we're keeping in that store. And so we just turn it off and we turn it back on when we need to debug. So you do sort of have to be aware that keeping all those past states is going to introduce some memory pressure, and it's going to make it a little bit more difficult on the main thread to walk through those states.
And since you can use that without the tooling, I'm assuming it's just tapping into the library itself to get those values, their previous values. Are there configuration options so you can maybe say, hey, I only want to keep the previous X number of iterations of that stack?
Definitely. As a configuration option out of the box, you can say only keep the last 5 to 10 states.
So one of the things that we've done with one of our apps is we've implemented state for essentially the shell of the application, right? The main nav and the shell. And then we have this staging area where we have different sub columns that come up with different data, like customer data, order data, that sort of thing. And so we keep state around the shell, and then those individual ones we don't do the state on. And that's been a pretty happy medium for us so far. It makes working with that shell and the concept of what's going on there really easy, but we've also been kind of hesitant because that data that's going to go into those the columns that go on the stage are all this customer data, all this order data, and it's I don't know if exactly the point Austin was bringing, does all that stuff going into the state really make sense in terms of in-memory and all this sort of thing?
Definitely. And, if you don't have the instrumentation turned on, the performance is actually going to be pretty great. So you're not going to really encounter too much overhead from this, from how much state you're keeping in the container. We do a lot of sort of performance tricks on our end. One of the important tricks is that if you've used ngrx store before, you might be familiar with this idea that you don't actually write just one reducer function. You're going to write reducer functions for a lot of different parts of your state tree, and then you're going to let the library combine those reducer functions into one function for you. And so we're going to, short circuit reducers if they didn't actually change state. We're going to be really intelligent about how we handle updating that state tree to try and keep performance to a minimum.
Yeah, you talked about reducers, right? One thing that, I see a lot, I've looked at Redux and things like that, is I feel like I just have so much boilerplate, right? With reducers, they're just everywhere. I want to do something really simple, right? Like toggle something, and I've got to have a reducer, and it's got to bubble it, and all that type of stuff. Do you have some feedback on that?
I would say that, yep, there's a lot of boilerplate. And that is a downside of this pattern. But it also, writing that boilerplate up front might save you sort of in the future. And we see that a lot in our large app, where when we were first working on it, yeah, we were writing tons of actions, we were writing a lot of reducers, a lot of it felt repetitive. But now when we're going back and trying to, change maybe the way that behaved, it's a lot more straightforward for us now that we've got all that written up front, and that it's easy to track state changes than it would have been if we had not followed this pattern. So it's sort of there's a cost, but it might pay off in the long run maintaining that app.
Is there any plans to, kind of bypass that? Are you familiar with like MobX, how they kind of, do decorators on top of, some of the attributes? And
I'm sorry, you broke up. Can you repeat that question?
Yeah, I said, is there any plans in the project to kind of reduce the reducers? I look at something like MobX, and I really like the pattern. I don't have to have a lot of reducers and things like that. I just decorate the things that I'm, keep track of, etc.
Sure. So probably from the core project, I wouldn't suspect we'll do much to try and alleviate the pressure of all that boilerplate. But I would definitely say, look what the React community has done. They're the big proponents of this architecture, and they've got a lot of really great tools that sort of minimize this boilerplate for you. For example, there's a great project called Normalizer that'll help you normalize, say, a REST call into a structure that's more consumable for ngrx store. Or there's a project called Redux or ORM, which sort of models your store as an ORM for you to get data out of it. And these projects both can save you a lot of time when writing these reducer functions. So
when I was
first solve it, we'll rely on the community to try and give us some solutions.
So when I first actually looked at Redux, and I was I'm getting off topic here talking about Redux, but I think the patterns kind of apply. I was starting to write all this boilerplate, and I actually tweeted to Dan, and he is awesome, very, very responsive. And he said, one of his opinions is if you're writing a lot of boilerplate and you're trying to hide a lot of this functionality, right, Redux, that pattern might not be for you.
Yeah, I would agree with that. And it's sort of one of those questions we get a lot is Redux right for my app? And to me, the answer to that is when we're talking about event sourcing and how you might have a lot of different event sources in your application, Redux is really great for the applications that have a lot of event sources. But if you're talking about just a simple CRUD app that's responding to user input and making REST calls, the pattern probably isn't going to make sense for that type of application. I work in IoT, and the kinds of apps that we work on are very live. We've got a WebSocket connection that's giving us continuous status updates. And we want to treat all those similarly and track all those changes in the same way. So the Redux pattern makes sense for our app because it's so live and there's so much interactivity to it.
Can you give us an example of I guess you just did, of what, might be a bad implementation, I guess, maybe like a to-do list or, a registration form maybe?
So yeah, really complex form models, those are difficult to do in Redux. And in those cases, that's one of the situations where I'd say almost, we're talking about what state should you not keep in the store. If you have a complex form, it's almost always going to be a little bit easier if you don't follow the Redux pattern for that. And then also, if your sort of domain model includes a lot of really nested relationships across many objects, because it's just a single state tree, rehydrating those joins out of that tree can be really expensive. So if you're working on an app that has these deeply nested models, it's probably not going to work out well for you there either. So those would be two examples of apps that I would avoid the Redux pattern in.
Yeah, that's great. I was actually going to ask that next. You can't really do OO with Redux. It's got to be primitives, and you've got to recreate all this. So there's a penalty, with making that, immutable per se.
Right.
Sorry. I just have one last question. Immutable JS. Do you suggest, people doing that?
If you're not well-versed in how to use sort of the browser's native APIs to write immutable reducers, then absolutely use it. It's going to give you all those guarantees up front. However, it's not necessary. I'm not going to show Immutable JS today in the demo code, but you definitely use it if you want those guarantees that you are writing immutable reducers.
Awesome.
Okay,
sorry to dominate the conversation here.
That's all right. Those are good questions. I think people want to know that stuff. But speaking of the demo code, I think we're all eager to see some of the stuff in action. So why don't you show us some stuff?
Sure. Okay, so I work in IoT, like I said, and so when I do demo code, I want to turn on the lights. So I'm going to just sort of briefly show what goes into writing this project. And going back to event sourcing, the way that I like to start is to think about all of the actions that are going to take place in this application. So I have just a basic app spun up here, and I'm going to make an actions file. And so in this actions file, I want to identify all of the actions that are sort of going to occur in this application. Because we're turning on the lights, we're either going to be, turn on light, or we'll be turning off the light, or we'll be dimming a light. And really, these are the only things that in this application the user is going to be able to do. They're going to be able to interact with a light component. Now, when they actually open up the application, we want to load all of these lights up. So there's also going to be a load lights action. This is going to happen when you start up this application. So the reason I've done these as strings is that every action needs to have a type of string and optionally a payload. And we have an interface for this in the library, so I'm going to import the action interface from ngrx store. So for every action, I'm going to create just a simple function that returns an action of that type. So for instance, turn on lights. It's going to return an action. Action is going to have a type and an optional payload, which for this moment I will leave empty. I'm going to write action creators for all of these, but for now I'm just going to do load lights. And by the way, while I'm working on these, I do want to point out that there are so many different ways you can handle this boilerplate. The action types object up here with functions return is one of the simplest ways that I know how to do it, but you'll find that there are many, many opinions on how to actually handle this.
Okay, and so right now you're writing action reducers that are, the pattern is designed to create the, action creators, right? That are designed to create the action instructions that are going to be dispatched somewhere else.
Definitely. So let me show you how you're actually going to dispatch these actions. So first I need to actually set up the store module. And to do that, I'm going to go into my app module, and I'm going to import from ngrx store the store module. And then in my imports, I'm going to do store module.provide store. And then you provide a dictionary of all of the reducers that are in your application. Right now we have not written any reducers, so I'm going to leave this blank. Going to my app component, when this is rendered, we want to fetch all the lights. So from those action creators, I'm going to import get all lights. I'm going to import the load lights action creator. There's only one service you're going to interact with when you're using ngrx store, and that is the store service. I'm going to inject the store, and he takes a generic parameter. This is typically the interface of your state tree. We've not written one yet, so I'm just going to do an empty object. When this app component is created, we want to dispatch that load lights action. And this will do, as I said, it'll create the action from load lights, dispatch it to the store, and all of our reducers that we might have created will immediately get this action. So now I'm going to write the reducer. In my light feature, I'm going to write a reducer that gets all of the lights. The reducer is just a function. And this function takes the state and an action. And we'll say in an interface that our state is going to have some kind of loading indicator. Now, this is one of the more controversial parts of Redux, but the way you handle every action typically is with a switch statement. So you're going to switch on the type of the action. And you can get the types from that object that I created earlier, action types. And for every action that this reducer wants to listen to, he sets up a case statement for that action like this. So when load lights occurs, I want to say that I am now loading the app, that I'm now in a loading state. But what I've omitted here is that I've not defined what my initial state is. So above my reducer, I'm going to create an initial state object. And I'm going to say that when this app starts up, I'm not actually in a loading state yet. And to let ngrx store know this is my initial state, I'm just going to say that if I do not have a state pass into me, use the initial state.
Can I ask a question real quick on that?
Definitely.
Should we be initializing our states that come into our reducers here like this? I mean, is that more often than not we want to do that?
Definitely. I would say that you always want to try and initialize it as a default parameter for your reducer. That's just going to prevent mistakes up front of you not remembering to set it when you're providing the store. So when this reducer is called with a state object and it's undefined, it'll be set to the initial state. But what isn't handled here yet is that if an action is dispatched that's not of type load lights, we're not actually returning a state. So I'm going to use a default case to just return state unmodified. So this is saying if none of my cases have occurred, just return state and don't change it. So now I've got to register this reducer. I'm going to go back to my app module, and I'm going to import this reducer as the light reducer. Now when I provide my store, I can say all the lights state is handled with the light reducer. And so if I were to subscribe to store now, you would see that there's going to be an object called lights, and it's going to have that loading parameter on it. I'm going to go to my app component, and I'm going to mark the store as public to put it on the class. And I'm just going to create a pre-tag and spit out all the stored state as a JSON object. The important part here is that store is an observable of state. So to unpack or to get the recent state out of it, I have to use this async pipe. And if you look over here, now we can see we have the lights key, and we do see that right now it's set to loading false. So I use the wrong action type here, save this. It should now be true once the app updates. Now, one thing we did not talk about beforehand was that Redux, these reducer functions are meant to be pure functions. That means they're not going to be communicating with the REST service, or they're not going to be handling anything to do with time. They're supposed to be pure functions. For any given input, they should always return the same output. So the question is then, okay, well, then where do I actually get these lights from? Who's responsible for making this request? We could say that we want to do it in the app component. But this comes with a disadvantage. Right now, our app component's sole purpose is to communicate with the store. He's getting state out of the store, and he's dispatching actions. Also giving him the responsibility to communicate to a REST service is maybe a little too much for this app component, and it's going to have the negative side effect of making him impure. Now he's the one who's doing all these side effectful code. And so in ngrx, we have a solution for this, and it's called ngrx effects. And what ngrx effects is it's a way to listen for certain actions in your application, do something that has side effects, and then capture the result in a new action. And they're really simple to wire up, so I'm just going to do an app effects. And these are services. So I'm going to import injectable from Angular core, and I'm going to create a class. This class is going to have properties on it that are these sources of actions. And to indicate to the library which sources are which, ngrx effects comes with an effect decorator and an actions service. So this action service is all of the actions that take place in my application. I can listen to any of them. And this is an observable, so I can use observable operators to filter down on this action stream. Here's my constructor. I'm going to put this actions observable on the class. And then I'm going to write a new effect called load lights, which is going to be equal to this actions. And it comes with this of type method. And this of type method takes an array of action types that we want to listen to. So I'm going to import that action types object. I'm going to say I want to listen specifically to you whenever you ask to load the lights. And I'm going to mark this as an effect using the effect decorator. So again, this action stream is an observable of all the actions that have taken place in the system. And this of type operator lets me listen for just a specific sets of actions. So now I'm listening just for load lights. And
so
when
in the observable, that's just like a filter, correct?
Yes, this is just like a filter.
Okay.
So I've already written a REST service to get all of the lights. And I'm going to import this service. I'm going to inject it. When I load these lights, I want to merge map into a new observable. This observable is going to be the actual HTTP observable returned by Angular's HTTP service. I'm going to add the operator. I'm going to say, when this action occurs, all lights. And this just returns an observable of all the lights fetched from this REST API that I'm interacting with. Once I've gotten all the lights, I now want to dispatch an action to let the store know you have all the lights. So I'm going to go back here into my actions. I'm going to make load lights success. I'm going to make an action creator. Takes all the lights, turns a new action. When the light success happens, my payload is not going to be an empty object. This time, my payload is going to be all the lights that were fetched from the API. Going back to my effects now, I can import this load light success action creator. And I can now map this observable and say, now that you have all the lights, map this into a load lights success action. So now this effect stream is an observable of actions. And what ngrx effects is going to do is it's going to subscribe this stream to the store. So every action that this observable emits is going to be automatically dispatched for you. You don't even have to think about dispatching that. If I go back to my app module and I import this effects service, I can use the effects module from ngrx effects to run these effects. And to do that, you use effects module.run, and you just pass in the service. It'll provide it for you automatically, and it'll subscribe to any of those sources that you've decorated.
And in terms of the order of the operations, will the effect run before or after the reducer function is run for that action?
Typically, it's going to be run after, but you should try to engineer the app in a way that it doesn't matter. So what I mean by that is, in your effects, the action itself should have all of the information on it for the effect to do something interesting. It should not actually have to read from store to know what to do. Does that make sense?
Yep.
One question I have, I'm seeing you import these modules, it instantly popped in my mind is, how does this play with AOT and Universal and things like that?
Sure. So all of this is AOT compatible. Just a forewarning though, if you do try to use ngrx effects with the Angular CLI, you might run into some issues. It's documented, there's a fix coming for it. But if you're using the compiler CLI directly, all this should work just great with AOT. So once we've got all the lights, now we want our reducer to both leave the loading state and to capture all those lights. So I'm going to go back to my light reducer, and in my state, I'm going to say I now have an array of lights. I'm going to get the interface for a light from the light model. The lights is an array of lights. And when my app starts up, I do not have any lights loaded yet. But when the lights are loaded successfully, we're no longer loading, and our lights are now on the payload of that action. Now once this reloads, we're loading, the request gets sent out, and all the lights are loaded into the store. And now we're ready to render these lights. Going back to my app component, I can actually get an observable of all the lights by selecting from the store. I'm going to import my light model again. I'm going to say I want an observable of all the lights. To get this state out of here, we sort of have to step back for a second and think about, what does our state tree look like? So we've got this key of lights. This is the state of all the lights. But then we have another key that actually contains the light objects themselves. So this light's observable is going to be in the light state, and we can use the select operator to select this entire object. And then once I have that object, it's going to exist on this key. For now, I've already written a light component. I should be able to iterate over all the lights that are in my store. So I'm going to say let light of lights async. Save the app, let it reload. All lights come in, and I've got my light components rendering. So generally, this is going to be the way that you're going to get state out of the store. You're going to put it into an observable, and then you're going to bind this observable in your template using the async operator. Once I have these lights loaded up, now I want to respond to its actions. And this is a pattern known as smart and dumb components, or you'll hear it be called container and presentational. There's a lot of different ways you can describe it. But in a Redux application, you want to separate your components into two groups. Your first group is going to be these smart containers, and their responsibility is to get state out of the store and bind it to the template, and then listen for events, map those into actions, and dispatch them. But for actual UI logic, you want to write what are called presentational components. And a presentational component doesn't have any knowledge of the state tree. He merely knows how to render data, and he listens for user input and dispatches events using outputs and event emitters instead of directly to the store. So this ngrx Lite component is an example of a presentational component. He has no knowledge of the store, but he has events that are useful to us. The first one is going to be a dim event. When this light is dimmed, he's going to fire a dim event, and the event will be the level that we want to set it to. So I'm going to say on dim, give me both the light and the new level that I should be set at. So I'm getting a light model and a level. Now I need to make an action creator to actually fire this action. So I'm going to go back into my actions. I've already written the action type. Now I just need to make an action creator. Dim light, and then the payload this time, it's not going to be just one object. I want to pass in both the light and the level. If I go back to my app component, now I can import from the action creators dim light. And when this event is handled, I want to dispatch new dim light action, passing in the light and the level. Again, this isn't actually doing anything interesting. We're just dispatching an action. There's no reducers listening for it. There are no effects that are listening for it. What we want to do is we want to go in and we want to actually change the state of that light to set its new level. So I'm going to go into this light reducer, and when a light is dimmed, I can get both the level and the light from the actions payload. And so I don't know if I am loading or not, right? But I can say that for the loading state, just return whatever it was last time. I don't really want to change it here in this action. What I'm more interested about is updating my list of lights. So my new list of lights is I'm going to map over the existing lights. So for every light, if this light is the same one that was changed, I want to modify it, but not mutate it directly. I want to return a replacement for it. So I want to change that light to have its new level. If it's not the same light, then I sort of want to move on and say, don't modify this one, leave it as is. Now if I save this, this reducer is now going to be listening for that dim action that we're dispatching in our app component. Lights are going to come in. If I dim it off, you can see the UI responds and knew how to handle it. If I bring it back up, the light will turn back on, and we see it updating live in our UI. This is great, but we're not actually making the rest call. This is where effects comes in again. So now I'm going to write a new effect called dim light. I'm going to say, when you want me to dim, let me actually delete this tslint file real quick so it stops yelling at me. When a dim action occurs, I once again want to make a request. And when I merge map this time, I actually care about stuff that's in this action. So I want to say this light service dim set level to the light that we want to update, as well as the level contained in that payload. This is how in ngrx effects you can get access to that information that exists in these actions. And when this occurs, it's not actually important to us to dispatch any new action, right? We've already updated the state. Our state's going to reflect the new dimmer level. So instead of mapping this to an action, in this effect decorator, I'm going to say, don't dispatch anything. Just subscribe to this observable. I know what I'm doing with it. I've already updated state. So this is going to update. Now if I do it with my slider, this will actually make a real network request.
Does the effect at this point have access to the state as well as the action?
So it could. You could inject this store service, and you could then choose to use combinators to get the state out of the store, if that's what you wanted to do, right? So an example of that would be like, I could import here the store from ngrx store.
You're not sharing your screen, FYI.
I'm sorry.
That's okay. I was visualizing it while I watched you type.
That's good. Just pretend like it's there. Okay. So I'm going to use the store. I'm going to inject it. And then this effect stream, before I did anything interesting, what I could have done is I could say, all right, with latest from this.store. It's an observable, so this would work, right? I could get the state out of the store just using this with latest from combinator. So that's a way you can get state out of it. But I recommend trying to avoid that approach, because generally in your action, you want to have enough information in that payload that your effects don't need to get state out of the store. It's sort of like, this is an escape hatch if you really need the state.
Hey, Mike, real quick, can you go back to that code? Oh,
Definitely.
you're still there. On line 20 there, you were using merge map. One of the questions that was asked in the YouTube channel was whether or not you could switch that from merge map to switch map.
Definitely. So the difference between a merge map and a switch map is that, let's say I was dimming the light a lot, and this network request to actually set the level of the light didn't finish. It's just going to keep going through, and that might not be the behavior you want. So what a switch map will do is, when a new action of dim light comes in, if that service request is still outgoing, SwitchMap will cancel the previous one and start a new one. So this cancellation can be really helpful if you are working with an API that knows how to handle canceled responses. The API that I'm working with right now does not, but that's a tool that you could use, and this would be interchangeable. So I'm going to take this merge map and import SwitchMap. I'm going to use those. Does that answer the question, Mike?
Absolutely.
Great.
Okay, I have a kind of a real world scenario question for you really quick on this stuff while we're in here.
Definitely.
So let's say in this scenario, you've got your state has all these lights, right?
Right.
Lights in there. And you actually want to have a higher level field, whether all the lights are on or off. Right.
Okay.
Or I guess something maybe a little different, like something that tracks, a result of this sub piece of your state. And so you have a reducer that's going to take, dim light, and it's focused on just that slice of the state, the lights, right, or the light that is dimming. Yet you want your state to then decide, oh, I also need to make it this global, this higher up thing say, oh, all the lights are off.
Sure. So this is an idea of like derived state. So you should think of the store as sort of a database. And from this database, you can make all sorts of kinds of queries from it. In this app so far, all we've done is we've gotten the lights out of the store. But what we could be doing instead is to take that list of lights and then maybe filtering or reducing over the list of lights to figure out if all of them are on or off. And so you wouldn't actually keep that state in your store. You'd want to derive that in a map function on the store observable, for instance. Does that answer your question?
Yeah, so then I guess the flip side of that is where you're using that, right? I guess that's where it kind of starts to unfold. And you say you have a component that wants to display whether all the lights are on or off. And is that now leading to select slices from the store and do these, mapping and stuff like that to get to that answer? Or would it be better and more performant to have this flag in your state that dictates that, and then that other component could just check for that?
Sure. So in terms of performance, you're not going to really see much of a hit either way with either of these scenarios. I would say in most situations, you're not going to want to have stored that flag in your store. It will be the responsibility of the component to derive that state from the store itself. Now, a problem with that is then, okay, so now I've got one component that knows how to get whether all the lights are on or all the lights are off. But what if I want to reuse that logic? What if I want multiple components to get this piece of derived state? And how can I do this in a performant way? And so I won't show the demo here because it's sort of supposed to spiral out of control if I start showing them. But there's this notion of a selector. And a selector is a function that can take state and perform this computation for you. And so what you can then do is say, okay, I've got this function that sort of encapsulates this way to get whether or not all the lights are on or off. Now any component can inject store, apply this function to the state, and we'll get an observable out of whether all the lights are on or off. To make this performant, what you can do is for this selector function, you can memoize it. And what memoizing means is that if you call this function multiple times with the same input, it's going to remember the last time it was called with that input and just short circuit itself and return its last known value. So that way, many components could use a selector. This selector is memoized. So even though you're creating multiple subscriptions, they're all really performant and fast because they know, or because the selector is memoized, and so it doesn't actually have to recompute every time. So there's a lot of sort of ways you could tackle this problem in a performant way.
Cool. Thank you.
So yeah, so for this demo now, if I were to stop sharing, go back to the app, and okay. Now I've got my light here. Do you guys see the screen okay now?
Yep.
So I've got my light here. If I were to now turn it off, or to set the dimmer down to 0, this light will go off and back on. So that's sort of the way that you interact with services and handle these complex side effects in your application.
That's really cool.
So I have one quick question. So we mentioned the fact of core and the store as two of the libraries that you have or packages, as well as the effects. Are there any other packages under the ngrx organization that people should be aware of?
So definitely store and effects are our two big hitters. Router store, the piece that connects your router state to your store, that's also an important package to be aware of if you're sort of buying into this ecosystem. We also have a few others that aren't used as much. So for instance, ngrx DB provides you an observable way to interact with the browser's indexed DB APIs in your Angular 2 app. And ngrx router, which I sort of have to bring up, was sort of the original reactive router that eventually became the Angular Router 3, or the router that's used today. So those are sort of our other big projects.
Nice. Is that IndexedDB one kind of ready to go and play with?
You could if you were brave. So it's stable, it's well tested, but there's not very much documentation. The source code is not very big though. Like you can sort of dig into it. You can see, okay, how are these observable pieces put together, and get a sense of how to use it. And if you want to see any examples or a bigger example of any of these libraries beyond what I just showed, we also have a full example application. So this example application, it's built with the Angular CLI. It will be AOT ready when Angular CLI supports doing that with custom decorators. And it demonstrates store, effects, router store, and the IndexedDB implementation I spoke of. The community's done a great job coming together, documenting it, and writing a lot of best practices around that application.
Awesome. Well, we'll get the links to those things for the episode notes, and we'll make sure we get those up there so people can get to that and check those things out. Well, this has been killer. I mean, I think we got a lot of insight into this ngrx story, and the stuff that you showed was pretty cool. Thanks a lot for joining us today and showing us all this stuff, Mike.
Definitely. If anyone has any questions, please feel free to hit me up on Twitter. I'm at MikeRyan52. I love to talk about ngrx, so just drop me a line. I'll answer your question.
I have one quick question.
Sure.
Is that API to turn your light on and off public? Can we share that to have everybody strobing your light all day long?
I will see if I can get you a link for that in the notes.
Nice. All right, well, let's wrap up with our picks. Anybody got some picks here? Let's go down the list. Austin, do you have anything?
Yeah, there's actually a new project by the Angular team. It's still in beta, but it looks really interesting for those, trying to use, grid systems and Flexbox and that type of thing. That is, I forgot the name of it. It's Flex Layout, and it's by the Angular team. There's
really
one other
awesome
thing
project.
that I have. Sorry? It's
a really awesome project. If you've not used it, Thomas Burleson, I believe, was sort of the mastermind behind that project. It's really cool.
Yeah. And then one other thing I had is there's this library called G2. This isn't Angular related, but it's called the Grammar of Graphics. And it's got some really awesome, I'm all about data viz, if you can't tell. It's got some really awesome chart and visualizations in JavaScript. It is in Chinese, so Google Translate will be needed for those of you that don't speak Chinese. But it looks really, really cool.
Nice. All right, Mike Brocky, do you have anything?
I was actually going to pick the Angular Flex layout as well. I've been snoozing on a reminder in my calendar to go and check that out. But yeah, I came across it and it looks really cool. So I wanted to check that out and was going to share that as well. So kudos to Austin for picking my brain.
Nice. So I have two things. There was recently, last month, a Forbes.com, well actually this month, Forbes.com article on Mishko titled Inventor of Angular and How Open Source Languages Are Redefining Enterprise Software. So that's pretty cool. Check that out. And then I also recently got, it should be here today, one of the Samsung smart home devices to do some home automation stuff, those little IoT stuff. So kind of going along with that, should be pretty cool. Check that thing out. Mike Ryan, do you have anything you want to add here before we close up?
I want to pick this actual print magazine called Offscreen Magazine. It's about our industry, tech and design and code, but it's off screen. So, beautiful photography, really interesting articles, a lot of really great information to consume when you're not connected.
Nice. All right. So we'll throw all those up in the episode notes. They'll be up on the website so people can check that out. Thanks a lot to all of our panelists, and a special thanks to our guests today for the show, and really appreciate it. And everybody have a great one, and we'll see you next week. We've got, what do we got next week? I believe it's, is Austin, is this your show next week?
December 6th, I think it is.
Yep, D3.
Oh, so that was a couple weeks now. Okay, so we got, let's see, I should know this. No, wait. Yeah, it is next week.
Yeah.
Angular and D3 for data visualization.
Yeah, I'm dominating the AngularAir here. Yeah, it's going to be really exciting. The team that I work with, we actually built a data visualization engine on top of Angular 2. So Angular 2 actually does all the SVG rendering and uses Angular's awesome bindingness and et cetera. And we're kind of just using D3 in the background for a lot of the utilities. So we're going to show that off and kind of talk about the evolution of what that was. It actually started as a React project, so that'll be a fun topic. And kind of show you, how it works and let's show some demos. So it'll be really fun.
All right. Well, tune in next week for that, and we'll catch up on that. All right. Thanks, everybody. Have a good one. Everybody take care.